Okay, let's continue. Okay, so back to this node. Before we stop, in the first session, we learned about a CRO. Okay, you need to understand how CRO works and the process of thermionic emission, and you need to know the every part of CRO in the CRO, starting from filament, which is cathode, then grid, control grid, focusing anode, accelerating anode, Y plate and X plate, and also screen. Then you need to know what is the output if you connect to a battery. Okay, if you connect to a battery, and what is the output if you connecting to AC supply when the time is on and when the time is off. Next, we go to semiconductor. Okay, semiconductor. So semiconductor basically in semiconductor lies on group 14, which is silicon and also germanium, which you learn in chemistry. Group 14 have 4 electron valence. So in order to make it stable, okay, to reach an octet stability, they need another 4. Okay, so they are sharing with each other and produce a covalent bond. But a semiconductor is a partially conduct electric. So to make it a better conductor of electric, we do a process named doping. So we dope with group 13, which is 3 electron valent, to produce a p-type semiconductor. Then we dope with group 15, or we dope with group 15 to produce an n-type semiconductor. Okay, now you have new semiconductor, not a silicon or germanium anymore. It's 2 type, either p or n. Okay, these 2 is a better conductor than the semiconductor itself. Okay, so p-type and n-type. So we have a component named diode. Basically, diode is a p-type and n-type being together. Okay, if you have 3 PNP or NPN, you put it together, it will produce a transistor, PNP and NPN. Okay, so now we go to diode first. Okay, this is diode. Same notes that I give you. This is diode. So a diode, okay, this is a symbol of diode. So the arrow always show you P to N. The arrow is showing you P to N. So that's why it's a P-type and N-type over here. P-type and N-type. So now you know that P as a whole and N have an excess electron. Okay. So to arrange a diode, you need to arrange it in this way. A positive battery need to connect to the p-type. Okay. So in order to make sure the current can flow, it's easy. You do like this. You know this is a battery. Current always flow from positive, positive, positive. Okay. Now you see the current flow. Either it's again or following the arrow of diode. Like this one, it is following the arrow of diode. That means current can flow here, can flow here. This bulb will light up. Okay, this arrangement is called as a forward bias. It's called a forward bias arrangement where a current can flow. Okay, forward bias is where a current I can flow. Then If you arrange in this way, positive and negative, so current flow from positive to negative, okay, current flow here, but there's a wall. So current cannot pass through the diode. So this bulb will not light up, and this arrangement is called a reverse bias. Okay, so forward bias is when the current can flow or is following the arrow of a diode, and reverse bias if the current cannot flow through the diode. Okay, that's a reverse bias. So therefore, diode, a function of diode is diode can make sure that a current only flow in one direction. So make sure that the current only flow in one direction. Okay. One of the function for a diode. So diode being used in the process name rectification. Okay. Name a process of rectification. What is rectification? Rectification is a process of changing an alternating current to a direct current. Okay, alternating current to a direct current. Okay, if you want to understand this like this, all right. So your plug, okay, household plug like this one. If you see above, I charge my laptop. Okay, this plug, okay, in your house, it supply an alternating current. Okay, supply an alternating current. While my laptop, okay, my laptop use a battery. So battery is a direct current. So they need to rectify or they need to change the alternating current from the power source into the direct current to the battery. So what is the component they need to change alternating current to direct current? They need a diode. Okay, they need a diode. So basically, your computer, your handphone, your many things, electronic device have a diode because it will change the alternating current to direct current. Okay. Hope you understand a little bit about diode. Okay, next. So rectification, there's two rectification. Either it's half wave rectification or full wave rectification. So for the half wave rectification, you only need a one diode. Okay, and you need to connecting the diode to alternating current, not a battery. Okay, this is symbol for alternating current because this diode is used for rectify to change the alternating current to direct current. That's why you cannot connect it to the battery. Okay. In this one, alternating mean, okay, first cycle is current flow to the top. Okay, so the arrow of a current follow an arrow of diode. So current can flow to the CRO, all right, and CRO give you the first output here. CRO give you the first output here. Okay. Then because it alternate, a current flow from the bottom. Current flow here, flow here, flow here, flow here, flow here. Oops, cannot flow. There's a wall. So a current cannot flow. There's no output on the waveform, on CRO. Then move from the top again. So you get the red one. Okay. Right? Next is full wave rectification. Okay, because first you need to remember what is the output for alternating current. Alternating current, the output is like this. Okay, the alternating current output is like that. And direct current for a generator, you have like this. Okay, referring back to the notes I give you yesterday relating to induction, where we learn AC generator and DC generator. So this is the output for alternating current and direct current. Okay, so a full wave rectification, you need four. You need four. So this one, you need to look it carefully. How do I do for the four diode? Okay, so I give you a number 1, number 2, number 3, and number 4. Okay, look it carefully. Okay, look it carefully. So first cycle, current flow from the top. Okay, till this junction, current have two choice. Either want to go through number 1 or go through number 2. Okay, so in your opinion, which diode the current can flow? Okay, Aina said that flow in number 2. So number 2, Najwa said number 2. Okay, why number 2? Okay, why number 2? Why number 2, not number 1? What is the reason? Okay, number 2, because number 2, diode number 2 is in, okay, good try, but not forward direction. Okay, good try, but it's called as forward bias. Arrangement is in forward bias. Okay, so it flow to number 2. Cannot flow to number 1, so number 2. Current flow here, cannot flow to number 4, same thing. 4 is reverse bias. So flow to the CRO, here, 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 going back to this junction. So then at this junction, so which one? I did flow diode number 1 or diode number 3. Okay. Number 3, because if go to number 1, circuit is not complete. You must go through number 3 to make sure the circuit is complete. Okay. So that's output, the first output. Then current flow from the bottom. So current flow from the bottom till this junction. Okay. So it can't flow through number 3. So it flow through number 4. Okay, flow through number 4. Same. Okay, same direction. Number 4. So then to this junction, meet here. Go to number 1. Okay. So complete circuit again. There's output again. So you get the second output. Then move to the top. Okay, then move to the top. You got the output again. Okay, can you understand how it works? All right. The main point is you need to remember only if you have one diode, it's half wave rectification. If you have two diodes, if you have 4 diodes, it's full wave rectification. And the output for half and full. All right. So in the bottom, okay, the difference is for this one, we have this component. This component called as capacitor. So this component is called as capacitor. So what is the function of capacitor? To smoothen the output, okay, voltage or output current. So capacitor alone, the function of capacitor alone is, okay, function, okay, function of capacitor is to store charge. Okay, that's a function for capacitor. If you put the capacitor in rectifier, the function is to smoothen the circuit. Okay, and next thing you need to see that capacitor is connected parallel in the circuit. Okay, capacitor must be connected parallel in the circuit. And that's the output. Okay, so what is the question being asked about this? Okay, we go to here. All right. If you see this, my first question is it a rectification process or not? Okay, so is it rectification or not? Okay, yes, right. So Aina, Patricia said yes. Okay, good. It is a rectification. Why rectification? Because here you can see alternating current. So half wave or full wave? Okay, half wave or full wave rectification? Half wave. Okay. So is there a capacitor or not? Okay, so there's a capacitor. So what will be the output? Okay, what will be the output? Okay, so the answer is A. So first you see one diode. So one diode, this one wrong because this full wave you need a 4 diode. So either A or C, but C is without capacitor. Without capacitor. This one with a capacitor. Okay, that's the main difference. All right. So another one, this one. Diagram show a circuit consisting of a diode and a bulb. When the switch is on, the bulb does not light up. Okay. So is this a rectifier? Okay. Is there a rectification? No. Okay, Akisha says no. Why no? Why no? No AC. Okay, good. There's no AC. This is battery. So if you have a battery or DC, that means this question want to ask you either the arrangement is in forward bias or reverse bias. So is the arrangement is in forward bias or reverse bias? Okay, good. Aina said in the chat room is in reverse bias. Okay, good. So the question is, what should be done so the bulb will light up? Okay, so what should be done for the bulb to light up? Use a new bulb, increase the number of dry cell, reverse the connection of dry cell, or connect a resistor. Okay, the answer is reverse the connection of dry cell. There's two ways actually. Either you reverse the dry cell or you reverse the diode itself. Two ways, ada dua cara. Reverse diode also can, reverse dry cell also can. Okay. So we go through the last one. Okay. Rectification, full wave or half wave. Okay, rectification, full wave or half wave or full wave. Okay, good. And is there any capacitor or not? Okay, good. Yes, Akasha said yes, Aina said yes, Christina also said yes. So which wave pattern is displayed on the screen of CRO? Okay, B, good. So this one is DC, no capacitor. This is DC, sorry, this is half DC. It's not DC, it's half wave. Okay, no capacitor. This is also half with capacitor. This is full but without capacitor. No C. No capacitor. So the answer is B. Okay, good. So we finish on diode. Okay. Is I'm too fast? Is it too fast? Either okay. Okay. So Aina said, okay, Najwa, good. Thank you. So I'm not too fast because we have two subtopic more. Okay, the next subtopic is not two. Yeah, two. Okay, next is transistor. Okay, so transistor. As I've told you earlier, transistor came from the semiconductor, P-type and N-type. You can arrange it in two ways. Okay, either NPN or PNP. Okay, how to differentiate? Most of the time in paper 2, they give you the symbol, and they ask you what type of transistor. So meaning either the symbol given is NPN or PNP. How will you know the type? Okay. So remember back the diode. When you learn the diode, an arrow, this arrow showing you that P-type to N-type. So the arrow show you that P to N. So you can apply to transistor. If you see here, the arrow is to the bottom. Meaning this is P, this is N. So the other one is N. Okay. Arrow here. This is P, this is N, this is P. So P and P. Okay. However, most of the question in SPM, I think all of the question in SPM that I have seen always ask you on the NPN transistor. I don't know why, but always NPN. Okay, it always NPN, but I don't know why. Okay, so there's two transistor. All right. So the symbol is, they start with C. C at the top, C is a collector. Okay, collector current. Okay, collector. B is base, and E is emitter. Okay, collector, base, emitter. Collector, base, emitter. So this formula state that IE or emitter current is equal to base plus the collector current. Okay. To understand that, it's like this. This is emitter current. This is the base current, and this is the collector current. Okay, this is the collector current. So from this battery, current flow here, current flow here, current flow here, flow here, flow here, flow here. Follow the arrow. So current flow to E. So IC, IE is IC. Okay. Then current flow from the base, okay, to the base, to the base. Here, follow the arrow, so current can flow to E. So IB. So emitter current is when the collector current plus with the base current. So the biggest current is E. Okay. Emitter current will be the biggest value. The second biggest current will be collector, and wrong symbol. Okay, emitter bigger than collector, and collector bigger than base. So the smallest current will be the base current. Okay, the smaller current will be the base current. Right. So first you need to differentiate the NPN and PNP, and then the basic principle is the same. If the current flow follows the arrow, okay, if the current flow follows the arrow, the current can pass through. If the current flow does not follow the arrow, the current cannot pass through. It's same thing, simple like diode. Okay, like diode, almost the same like a diode. Okay, so what is the function for transistor? So for diode we use in rectification. Only one. The application is only one. Transistor, you learn that the application is two. First is to amplify the current. The second one act as automatic switch. Most of the time, the question will ask you about this. Transistor act as automatic switch. And most of the time, automatic switch is this one, a light dependent resistor. Okay, a light dependent resistor. How it's work? Okay, how it's work? So if you see the difference between this picture and then this picture, okay, this picture and the picture at the top. Okay, same thing in your note. So the picture at the top, you have two battery, which is current at base and the current at the collector. Okay, so how it can be used as automatic switch is like this. Okay, so for transistor, The most important for transistor is you need to have a base current. If you have the base current, the transistor will switch on. Okay. Let me explain. So if you see here, current flow from the top. Okay, current flow to the top, to here, to here. And if you learn electric, when there's two-way the current pass through, they will go here and go here. Okay. But even though the current can flow through the bulb still does not light up, because the circuit will not complete if this one is off, if the transistor is off. So to make sure the transistor is on, so current flow here, flow here, flow here. Okay. So to make sure current flow, this is base. Okay. To make sure current flow to the base, this LDR or light dependent resistor, which is the resistance depend on light. Okay. Resistance depend on light. Right. So when this resistance is really high, current will flow to the base. Now there's a base current. Transistor will switch. Okay, there's a base current, so transistor will be on, not off anymore. So when they're on, current from the top can flow through the transistor and complete the circuit. And this bulb will light up. Okay, so it's just an explanation for you to understand how it works. So the one that you need to remember is this. You need to remember where's the LDR located. Where's the LDR located? If you see the LDR is at the bottom, that means the bulb will light up during dark or night. Okay. If you see the arrangement, LDR is at the top, that means the bulb will light up during days or bright. Okay, so you need to see the position of LDR. If LDR is at the bottom, light up during night or during dark, and if at the top, light up during days. Okay, so let's see the question first. Okay, the question is, which transistor circuit will light up the bulb? Which transistor circuit will light up the bulb? Okay. As I told you earlier, you need to see where's the current flow. If the current flow follow the arrow of the transistor, it will light up. If the current cannot flow or follow the arrow of transistor, okay, will not light up. So which one? The current follow the arrow in the transistor. So which one? Okay, D. All right. Okay, Aina try D. Okay, Christina said C. Okay, Christina said C. Right. As I told you, you need to follow the arrow of current. So sekarang current flow to the top, follow here, follow here, follow here. Okay, it look like A is correct. It look like A is correct. Okay, wait, we go to the B. So B, current flow to the top, flow here, and flow here. Okay, so for this one, this way. Okay, but the arrow is against the arrow. The current flow against the arrow. So this one is wrong. Okay, 4D, this one, this one, this one, this one. Okay, current against the arrow. So this one pun tak boleh. Okay, C, current flow top, here, here. Right, so current flow the arrow. Look like C and A is correct. But the answer is C. Why? Because A does not have a base current. No base current. No current flow to the base. So A is wrong. The answer is C. Okay. So we have less than 1 minute. We need to rest first. I think we rest around 3 minutes, around 2 to 3 minutes, 4 minutes, I think. So we start again at 10:30. Okay, now it's 10:26. We start at 10:30. We finish this question and last part of this chapter, which is logic gate. Okay. All right. So we take a rest first. Go through the question. We discuss the question afterwards. Okay.